we can use substitution here. Because we know that y equals 2x plus 3, we can replace the y over here with 2x plus 3. In doing so, we have x plus 2 lots of 2x plus 3, and I'm going to put brackets when we're substituting the y, and we're going to make that equal to 6. Now, the next thing we're going to do is to expand and simplify and solve for x. So the first thing we do here is expand. 2 times 2x is a 4x, and then 2 times 3 is a 6. So plus 6 is equal to 6. The next thing we're going to do is move the number to the other side, take away the 6, makes it a 0 over here, and we're going to get an x, and a 4x makes a 5x equals to 0, which means x equals 0, which is exactly what we anticipated, because as you can see on the graph, x is equal to 0 as one of the ordinates. The other value is the y value. Now we have to back substitute, so don't forget, when you found your x, you're not done yet. You need to go back and find the y. So we're going to take x equals 0 and chuck it in here. We get y equals 2 times 0 plus 3, which makes a 3. Therefore, the point of intersection, so I've abbreviated that, is 0, 3. Okay, so that's that. We've used algebra to figure out the point of intersection. Now, we're going to go back to the top and have a read of it. There are 2 methods that can be used to find the point of intersection between 2 equations. It can be 2 straight lines, or it can be 2 different equations. It doesn't have to be straight lines. There's the graphical method, which requires sketching the 2 graphs accurately on a number plane and reading the point of intersection off the diagram. Now, we would like an accurate sketch so that we can precisely see the point of intersection, or points if there's more than one. Algebraic method uses simultaneous equations to solve for the point of intersection. Okay, so we carried through that method over here. We use simultaneous equations by bringing the 2 equations and making them into one. Okay, now we're going to move on to the next example. Oops. Okay, so over here it says use the graphical method to find the point of intersection between the line y equals 2x plus 3 and the parabola y equals x squared. Now, using the graph, we can see that there are 2 points of intersection. There's one and there's the other. Now we can label this point, that would be negative 1, 1. So we're going to label it negative 1, 1. And the other one is going to be 2, 9. Now, the algebraic method to find the points of intersection, you should get the same 2 solutions, so the same pair of solutions. If you don't, then because it doesn't match up, there could be a mistake in either one of them. Now, we're going to go on to continue and do the algebraic method. Y equals x squared, y equals 2x plus 3. So we're going to write them out. Y equals x squared, y equals 2x plus 3. Now, we know that both of these equations are equal to y, which automatically means that they must equal each other. Alternatively, what you can do is, well, y equals x squared, so replace this y with an x squared. So substitute x squared equals 2x plus 3, which has the same effect as, well, if they're both equal to y, then they're both equal to each other. It follows. Then move it to one side, x squared minus 2x minus 3 equals to 0. Product and sum, x minus 3, x plus 1 equals to 0. And then x equals 3. Oh gosh. X equals negative 1. I don't know how I made that mistake, but apparently I did. Sorry guys, it's late at night. I should be sleeping. Anyway, I hope you're all alert and you picked up on that before I did. So as I was saying, by the way, I'm just testing you here. It's all just part of the plan. It should add up. So when x is equal to 3, we then need to back substitute. We get y equals 3 squared, which is a 9. So for this pair, we have 3, 9. And then over here, when you sub x equals -1 into x squared, you get a -1 squared, which is a +1. So we'll get -1, 1. Again, as I was saying, they should both add up. If they don't, then there could be something that is incorrect. So yeah. Okay, so finally, last example. We're looking at use the graph to approximate the point of intersection between the line y equals 3 minus x and the hyperbola. Okay, so the hyperbola is given, we're looking at the asymptote, so -2, which is what we would expect because the denominator can't be 0. And of course, we're looking also at the x-axis. So we've got the x-axis here, y-axis. I'm just filling things in. That's the equation, x equals -2. Anyway, find the points of intersection. Now there is more than one, so we are going to fill that in. Points of intersection. Now we do need an approximate here because, as you can see, you won't get an accurate value on this one. So we're looking at 0, there's a -1, so maybe like a -1.6 or something like that. And we're looking at a 4, so that's jumping, that's 3, 4, that's a 5. So we're looking at about a 4.5 there. And then over here on this end, you're going to have, well, that's a 3, so about a little bit more than a 5, so 2.6. And again, if that's a 1, then that's going to be about a half on the y value. Okay, so now we're going to find the points of intersection using algebra. So we'll get started on that. The first thing we're going to do is to make them equal to each other. Because they are both equal to y, it follows that they must both be equal to each other. So 3 minus x equals 2 over x plus 2. Now we're going to times up that denominator to get rid of the fraction. So we're going to have 3 minus x times x plus 2 equals to 2. And then we're going to expand that out and simplify it. 3x plus 6 minus x squared minus 2x equals to 2. And now we're going to collect like terms and simplify. You can also move it to one side. So I'm going to get this in the correct format. First of all, -x squared, 3x minus 2x is an x, so positive x plus 6 equals to 2. I'm actually going to move the 2 to the other side. -x squared plus x plus 4 equals to 0. And now divide through by a -1. So dividing through by a -1, we get x squared minus x minus 4 equals to 0. And at this point, we're going to make an informed decision based on the previous values. We're going to pretty much deduce, but you can also check by product and sum. If the product is -4 and the sum is -1, then really there's no two numbers which exist, which means we're going to make an informed decision and use the quadratic formula. X equals minus b, so minus 1, which is a positive 1, plus or minus square root of b squared minus 4ac all over 2a. And that'll simplify to give us, 1 plus or minus square root of, we're looking at minus 1 squared minus 4 by 1 by minus 4, which is a 17 over 2. Now I'm going to substitute these decimals just to have a look at what the accurate values are compared to what we had in the graph. So let's have a look. 1 plus root 17 over 2 is about a 2.6. there you go. 2.56 is the more accurate response. Now I'm going to leave this in exact form. So I'm going to leave it insert form and not simplify it. I'm just showing you what our estimate fares in comparison to the accurate answer. 1 minus square root of 17 all over 2 is negative 1.56, and we had a negative 1.6. So I would say that these approximations are quite nice. So try, when it comes to an approximate, so sometimes you may get asked for an approximate, you know, point of intersection. Try and be as close as possible. So, you know, it's up to the marker to judge, but try and be as close as possible. Turning over, sorry, that was my kids. Anyway, what is the point of intersection between the line 2x plus y equals 5 and the circle? So we're having a look at the graph here, and going off the graph, you can see there's one point of intersection there, which is the point 0.5, and there's the other point of intersection there, which is the point 4, negative 3. So now we're going to use algebra to pretty much figure out the accurate answers. So we're trying to confirm these estimates, these points of intersection. Using the graphical method, we're trying to reaffirm that answer, so to support it. Let's have a look. 2x plus y equals to 5. That's equation number 1. The second equation is x squared plus y squared equals to 25. Now, in this case, we have an x squared and a y squared, whereas over here we've got an x and a y. So we need to make something happen so that we can bring the two equations together, because right now it's going to be a bit tricky. Now, the first thing I would do, and I would encourage you to do, is to make y the subject here. So move the 2x to the other side, 5 minus 2x. The next thing I would encourage you to do is to square both sides. So square the left-hand side, you'll get y squared. And what you do to one side, you must do to the other. So we're also going to square the right-hand side. 5 minus 2x all squared. And then we're going to expand this out and simplify it. Expand it out. 5 squared is a 25 minus double that is a 20x plus a 4x squared. And now we have a y squared to work with, which is great. We know y squared is 25 minus 20x plus 4x squared, so we're going to chuck it in there. And hopefully bring the two equations into one. So that's now equation number 3, and we're going to say sub 3 into 2. Sub equation 3 into equation number 2. So we get x squared plus 25 minus 20x plus 4x squared is equal to 25. And then we're going to collect like terms and simplify. 5x squared minus 20x, and try and put it in order. If we move that 25 to the other side, it cancels out to become 0. So we're now going to, how would you do this? Factorize the 5x first. You'll get 5x, x minus 4 equals 0. The next thing you would do is to get an answer from here. 5x equals to 0, which means x equals to 0. Or x minus 4 equals to 0, which means x equals 4. And then finally, you found your x's. Don't forget, when you're finding a point of intersection, you have to find the y. Why is that? Because a point is an x with a y. It's a coordinate. It's a coordinate. So please, people, when you find x equals 0, sub it back into the original. Obviously, going with the linear expression is the best one to go with, because you're not involving any squares and you don't have to square root, etc. So we're going to go for that original equation, the first equation, the linear. When x is equal to 0, sub it in, you get y equals 5. So one of the points is 0, 5, which is as expected. And then the other point is going to be, if you sub x equals 4 in there, you'll get an 8. Move it to the other side, you'll get an, if you get sorry. If you sub in the 4 there, you'll get an 8. Move it to the other side, you'll get a -3 for y. So doing that working out, you'll get 4, -3, which is as expected. Okay, and I think that's a wrap. So don't forget, for those of you who haven't, please subscribe to my YouTube channel, and don't forget to hit the like button. Thank you.